All right, students into Math Connections on 14.1. If you take a look, MCs, we have 2, 4, 5, 7, 12, 21, 25. Let's take a look at these. So 2 and 4 to 5. So given two parallel lines, explain how to transform one into the other using the following. So think about this. If you're going to do this on tracing paper, if you kind of want to see the idea, you need to draw two parallel lines. That's what you're given. Then how can you transform one onto the other using the following? So if you did just a rotation, you have to be able to tell me a center and an angle of rotation. What would that take for one of them to rotate and sit right on top of the other? For the second, it's a translation. How would you move from one to the other? And it says, again, describe all possible translations. So there you go. You have to, again, explain how. It doesn't say you have to do it. You have to explain how to do it. Okay, so that's 2, and then I think what, 4 to 5? 4 to 5. Okay. So for each of the following, trace the figure on tracing paper. Patty paper is just fine, right? Trace it. Rotate it 180 degrees about 0.0. So each one of these has a 0.0 listed. Then sketch the new image and then make a conjecture about what kind of figure is formed by the union of the original figure and its image. Think about the union, meaning the idea that I'm actually going to put these together. So it'd be one shape. And then explain why you think your conjecture is true. So maybe you say, hey, I think this is a rhombus. Then you got to be able to explain why you think it's a rhombus. Okay. Question 5, wheel A has half the perimeter of wheel B. If wheel A is rotated 180 degrees, how many degrees is wheel B rotated? So A is going to go around 180 degrees as you kind of put this kind of in your head as saying, hey, what am I doing here? Take wheel A and think about starting point wherever, and you're going to rotate wheel A 180 degrees. Okay. How many degrees is wheel B rotated? Okay. Now it will rotate in the kind of the opposite direction, right? Because it has kind of gears, and that's how gears work. But does it go all the way around? That'd be 360. To go halfway around, that'd be 180. Is it less than that? How far will it rotate? Okay. All right. What do we have then? 7, 12. So 7, ABC is a right triangle. Squares are on one leg and the hypotenuse. Line CN is perpendicular to AB and FG. Okay. Use the concept of rotation and the result of problem 6. So again, I didn't assign problem 6 specifically, but you can use the result of it, so you don't have to go through and solve it. When a line is rotated 90 degrees clockwise, its image is perpendicular to the line. So if you rotate an image 90 degrees, then you rotate a shape. And again, they're starting with concept of rotation. So if you take E, A, B in a sense, and you rotate it 90 degrees, right? So this bottom line here becomes this side of the square. You get a new triangle, right? CAF. And what they're saying is when you do that rotation, when you rotate it 90 degrees, then the image is perpendicular to the line. So if you had something originally, and that would be, if you think of this line right here, and you rotate, you rotate, and you have this line right here, one, you rotate 90 degrees, it's going to be perpendicular. Okay. Explain why CF, now here's CF right here, and EB. Maybe I should choose a different color. CF is here, EB is here. So why are those two congruent and perpendicular? So you get a beautiful piece here about rotations, right? So if you had rotated this component, then you'll have exactly the same piece. And we have squares on one leg and the hypotenuse, okay? So this gives you an opportunity to show why CF and EB are congruent and perpendicular. Again, you can use the piece up here for justifying. I think that's pretty helpful. Nudge, nudge, wink, wink. Next up was question number 12, which is right up here. Explain in your own words why only 3 types of regular polygons tessellate the plane. This is something we will be going through in class to demonstrate why that must be the case. But yeah, hint, hint, probably a good test question. Now let's see here, 21 and 25. So these are the questions from the classroom then. So 21, 2 congruent circles, A and B, are the same distance from center A. Circle A is rotated 270 degrees. Let's see here, 2 congruent circles. Oh, as shown. So I bet it's on the next page right up here at the top. Here we go. Okay. Okay, so this is the image they're talking about. It's on the next page. Okay, and it says, Stuart, Allen, Lucas drew the following answers, and it says 2 congruent circles are the same distance. Circle A is rotated 270 degrees clockwise, and circle B is rotated 180 degrees clockwise. Look at the answers, because you're going to have Stuart, Allen, and Lucas. Who is correct? And try to see if you can figure out what is the incorrect portion. What was the misconception that the other student did? Okay. There's 21 and 25. Jillian wants to know why a regular pentagon will not tessellate the plane. How do you respond? And again, this will probably come from some of the work we do in class, but you might be able to get there with just what's in the textbook, and that's perfectly fine. All right. That's it. Not a ton of them this time. Not a ton. So if you have questions, please let me know. I can make a video, meet you in class, meet you after class, on campus, on Zoom. Let me know how I can support you. All right, off you go.